In this proof of concept, the Velociraptor server was configured on an Ubuntu VM, and the Velociraptor client was configured on a Windows VM. An attack simulation was conducted on the Windows VM using a Kali machine in a safe and controlled setting. Creating a process hunt. The 1.exe reverse shell was executed on Windows VM, connecting to Kali. Command prompt was switched to PowerShell. In Velociraptor, create a new hunt. In the Configure Hunt tab, add the description process hunt. In the Select Artifacts tab, search for PS tree. Select Generic System PS tree. In the same tab, search for PS list. Select Windows System PS list. This artifact list processes and their running binaries. In the Configure Parameters tab, edit Generic System PS tree. Select Include PS tree. Select Review, then Launch. Select the hunt and click the play button to run it. Wait for it to finish. This may take some time. Once the hunt is complete, indicated by finished clients, click the Stop button to stop the hunt. Check the results on the Notebook tab. Filter by most recent start time. As shown in the red circle, the suspicious activity is detected. Adding client labels. To create a label, click the magnifying glass icon, select the target host, then click the label icon. Name the new label, for example, Windows. Verify that the label has been added to the client. Creating a file name search hunt. Create a new hunt with the description file name search. On the Windows Server VM, a malicious PowerShell script called justascript.ps1 was created then removed. Back on the hunt, select Match by Label for Include condition. Select Windows for Include labels. On the Select Artifacts tab, type file name and select Windows Forensics file name search. On the Configure Parameters tab, click spanner icon to configure. In the Yara rule, replace mysecretfile.txt with justascript.ps1. Select Review, then Launch. Select the hunt and click the play button to run it. Wait for it to finish. This may take some time. Once the hunt is finished, click the Stop button to stop the hunt. View results in the Notebook tab. As shown, Velociraptor detects that the script is in the recycle bin. We can also see create time, file modified time and access time. Creating a hash hunt. Create a new hunt with the description hash hunt. Set include condition to match by label and include labels to Windows. Mimikatz, renamed as just an exe, was executed. On Kali, generate the SHA-256 hash of Mimikatz using the SHA-256 sum command and copy the hash. In the hunt, go to the Select Artifacts tab, search for hash, and select Generic Detection Hash Hunter. On the Configure Parameters tab, click the spanner icon to configure, and paste the Mimikatz hash into the SHA-256 list. Select Review, then Launch. Start the hunt by clicking the play button and wait for it to finish. This may take some time. Once the hunt is finished, stop the hunt by clicking the Stop button. View results in the Notebook tab. As shown, Velociraptor matches the SHA-256 hash with just an exe. Despite the name change, the Mimikatz was detected. In this proof of concept, Velociraptor was deployed as the server on an Ubuntu VM and as the client on a Windows VM. We simulated attacks from Windows and Kali machines, showcasing process hunts, client labeling, file name search hunts, and hash hunts. Even after renaming or deleting files, Velociraptor detected them, highlighting its strength as a robust digital forensics tool. For more details, refer to the Cyber Defense Kit documentation.